All right, so hopefully everybody did fairly well with the empirical probability. So with our theoretical probability, so in this case, again, instead of actually doing something, flipping coins, rolling dice, or anything like that, we're just going to observe how many ways our event can occur by just kind of counting what all the possibilities are, and then divide that by the total number of all possible outcomes in order to get our different probabilities for these. So with this one, we're example 4, we're rolling just a single die one time. So again, just to remind us, our sample space is going to look like 1, 2, 3, 4, 5, 6. And so this is going to be our total as well. So our total number of things is equal to 6. So that's going to be our bottom number for all of these different fractions that we're forming. And so if we look, what's the probability of rolling a 4? So in this case, since there's only one 4 in our list, there's only one way to actually roll a 4. And since there's 6 total outcomes possible, our probability of rolling a 4 is just going to be 1 over 6. And so if we wanted to turn these into decimals, all we'd have to do is just divide 1 over 6 and then move the decimal point 2 places and stuff like that. And so with this one, we'd end up getting 1 divided by 6 is 0.1666666 repeating. So if we move our decimal, we're going to get 16.7%. But I'm just going to leave these as fractions for right now, but feel free to change these over to percentages if you want to for practice. All right, so B, we've got the probability of an even number. So what we're looking at are the numbers 2, 4, and 6 are only even numbers in this case, and since we have 3 of them, then our top number is going to be 3, and our bottom number is just going to be, again, 6. And so 3 over 6, of course, the same thing as 1/2, so this is going to be 50%, so that one's easy to calculate. All right, so C is kind of a trick one. So we're looking for a number greater than 10. And so if we look at our sample space, is there any numbers that are greater than 10? And so hopefully everybody's saying no at this point. So the probability of a number greater than 10 is going to be 0 over 10, or 0 over 6, sorry. 0 over 6, which is going to give us a 0% probability. So again, there's no way this event is ever going to occur, so it's 0%. And then for D, we've got the probability of a number less than 20. And so in this case, if we look, even though our numbers only go up to 6, 1, 2, 3, 4, 5, 6, every one of those numbers are less than 20. So that means there's 6 numbers. That's where this event occurs out of 6 total. So in this case, that's going to give us our 100%. So this event is going to occur all the time. So, all right, perfect. So that looks good for our rolling one die. And it gives us a chance to think about some different examples here. All right, so example 5 is using our 2/4 situation that we had before with our sample space. So again, I'm just going to quickly jot down our sample space here so we have it to look at. So in this case, our sample space consisted of 4 elements. So our bottom number for all these problems are going to be 4. So in the first case, we're trying to figure out what's the probability of flipping 2 heads. So that's going to be this one and only one. That's the only place where we get heads and then heads again. So in this case, we've got one possibility out of 4 total for a probability of 25%. Now for one head and one tail, so in this case, we've got both these two have one head and one tail, so it doesn't matter which order they come in or anything like that, as long as there's a head and a tail paired up somewhere. These possibilities out of 4. So that's our 50%. So now at least one head, so in this case, this means one or more. So when you hear the word at least, that means one or more. So at least is the same thing as one or more. So what we're looking for in this case are, this one has two, but still more than one. So for our one or more, we've got three possible outcomes that have that out of our four, which is going to be 75%. So that looks good. And then finally, no tails at all means that we're just trying to figure out, well, which one doesn't have any tails. So we wouldn't want to include this one, or this one, because those all have a tail in them. So this is the only one that contains no tails. So again, that's just going to be 1 out of 4, or 25%. All right, perfect. So again, with theoretical probability, we're just trying to count up how many possibilities are there, divided by the total number, and that'll give us our fraction, which we can then turn into a percentage. All right, so what I want you to do is kind of work on the next couple practice problems. So I will talk a little bit real quick about the decks of cards, just in case people aren't familiar with decks of cards. So I put them on here so you can get an idea of what the sample space looked like. So decks of cards are broken up into 52 cards total, where there's 4 suits, and then with 13 cards in each suit. So in this case, the top row is called our club suit. The second row down is hearts. The third row down is spades. And the fourth row down is diamonds. And so notice that we've got different colors. So we've got either black or red. So these two obviously make up our black cards. And if we count them up, there's going to be 26 black cards, for example. And these two together are going to, of course, make up our red cards. And again, there's 26 of each of those. And then we've got some special cards that are in our deck. So notice these 3 columns at the end. So these are what are called our face cards, clearly because they have faces on them. So these are considered our face cards. And if you add them up, we'll see that there's 12 different face cards. And then starting with the 2 up to the 10, so these are our number cards. And so with those, we have 9 in each suit. So 9 times 4 gives us 36 total number cards. And then finally, the ones with the A's on them, these are their own special kind of cards. And these are called aces. And so there's only 4 of those. And so the main thing to remember is sometimes in cards games, aces count as numbers and stuff like that. But for what we're doing probability-wise, aces are going to be their own separate thing. So aces don't count as face cards. Aces don't count as number cards. Aces are only going to apply when there are aces and things like that. And since there's 52 cards total in the deck, all of these answers that we come up with are going to be something over 52. So for example, the probability of drawing an ace, since there's 4 total, would be just 4 out of 52 for that. All right, so if you have any questions about cards or probabilities or anything in general, just definitely send me a message and stuff. So in the meantime, we'll work on practice 4, practice 5, practice 6, practice 7. And so unfortunately, since we're not in class, like normally we would do practice 8 in class where I'd bring in M&Ms and stuff like that, and we'd go through that one. So don't worry about practice 8 or anything like that. You can skip this one since we can't really do this as a group or anything. And then we'll be ready to move on to 3.2 next. So again, send me a message if you have any questions. Otherwise, I'll see you in the next video.